All right, here we go again, Math 9. As promised, we're moving from fraction basics now to equivalent fractions and comparing fractions. So now we're working with those fractions, not as decimals, but as fractions. So remember that the denominator is the number that the fraction has been broken into, and the numerator is the number of pieces you have. And you can see I picked 2 over 4 for a reason, because a lot of you might be thinking, well, that's just a half. And it is, and that is an equivalent fraction. So an equivalent fraction, a half, is equal to 2/4, is equal to 4/8, right? There's an infinite number of possibilities, but the question is, how do we get them? So we actually tie in some multiplication here, but if I want a denominator, let's say I want to know what 1/2 is when I have a denominator of 10. Well, how do I get to 10 from 2 using multiplication? I have to multiply 2 by 5. 2 times 5 gives me 10. But since I want something equivalent, I need to multiply the top by 5. And the reason why I do this is deeper than just doing the same thing to the bottom as I am to the top. Look at what's happening. You're doing 1/2 technically times 5 over 5. That gives you 5 over 10, which is equivalent. But it's because 5 over 5, the same thing to the bottom as you do to the top, is equal to 1. And when you multiply something by 1, you just get that something back, right? So in this case, we're multiplying a half by 1, but we're multiplying it by 1 in the form of 5 over 5, which is why we end up with a different looking fraction, 5 over 10, but the same value as 1 over 2. Right? So we are creating an equivalent fraction that has the same value, it just looks different. All right? So let's look at one more example and then we'll move on. I think there's some more on the next page. So if I have 3 over 4, 3/4, and I want an equivalent fraction, and I want to know what it is when my denominator is, let's say, 56. Well, how do I get from 4 to 56? I multiply by 9. So how do I get from 3 to 56? I multiply by 9. Remember that this is just 1, which is why my value does not change, but my appearance changes, because 3 times 9 is 27. So 27 over 56 is exactly the same as 3 over 4. You can go the other way. You'll see this when we do simplification, but you could go like this. How do I get from 56 to 9? Well, I've divided by 4 and I divide by 4, because you're still dividing by 1, but we don't look at it like this as much because we focus more on I can't divide by 4, I can't divide 27 by 4. I can divide by 9 and divide by 9. Sorry, I did that backwards. Divide by 9, I get 4. Divide by 9, I get 3. What we call that simplification, and you'll see how that works a little bit differently when we simplify. So equivalence, same value, look different. So this is exactly what I talked about. You have 3 over 5. You want to get to a denominator of 15. So you're multiplying by 3 and you're multiplying by 3, which is 1. That's the caveat we talk about. It's 1, but in the form of a fraction. So we end up with 9 over 15. I covered this on the last slide, so I'm going to keep going. Let's do 2 more examples here. So I got 2 over 7, and I want to get a denominator of 28. Well, 7 times 4 is 28, so 2 times 4 is 8. Those are equivalent fractions. We'll do one more. You don't always have to compare the denominator. You can say, well, what if I have 3 over 9 and I want to get a numerator of 12? Well, I would have to multiply 3 by 4, which means I would have to multiply 9 by 4. So it works either way. Just make sure you do the same thing to the bottom as you do to the top, because we are multiplying by 1. Okay, so what about comparison? Comparison is going to pull in exactly this concept of equivalence. Because if we're comparing 2 fractions, if I were to ask you, are these fractions equal, less than, or greater than, right? This means less, the one on the left is less. This means the one on the left is greater. So if I gave you two fractions and I said, okay, which one's bigger, 1/2 or 3/7? Well, some people might be able to say, well, 3 is less, half of 7 is 3.5, 3 is less than that, so that's less than a half, so obviously 3/7 is less than a half, and that's great logic. But let's get into being able to compare things mathematically, because as your fractions change, the numbers could get closer and closer together, and it's harder to justify in that respect. So the easiest way to do this, because if you think about your ones right now, remember your ones are the same size. I'll try my best to make those look the same size. This one's split in two, and this one is split in sevens. So it's really difficult to visualize this. So rather than visualize it, let's get ourselves the same size pieces, i.e., let's get a common denominator. So if I multiply this by 7, and I multiply this by 2, I'm going to end up with a fraction that has a denominator of 14 and a denominator of 14. So now I have the same sized pieces. But then I just do the same to the top because I want to make an equivalent fraction, and the same to the top. So this one's the same and this one's the same because I'm just making equivalent fractions of both, but in a way that gives me a common denominator. And now I have 6/14. Because if you have the same size pieces, right, the 14, all that matters is which one do I have more of? And in this case, I have more with 7 than I do with 6. So if 7/14 is bigger than 6/14, it means 1/2 must be bigger than 7/3 because they are equivalent fractions. So by getting a common denominator, it solves all your problems of having to justify it maybe visually or justify it logically, because the fractions will get very small. So here is another example of what I did, except I'm not going to compare them here. I am going to find a fraction in between a fraction. And spoiler alert, there is an infinite number of fractions between any two fractions. So it's just crazy how many fractions there are. That's why we want to get comfortable with them. So in order to figure out what's in between them, again, common denominator is helpful. So multiply by 2, multiply by 2, multiply by 7, multiply by 7. So now I get 8/14 and I get 7/14. Well, you might say, well, there's nothing in between that. One's 7 and one's 8. But there is. Because what's in between 7 and 8? Well, 7.5, 7.1, 7.2, 7.11113, right? There's an infinite number of numbers in between 7 and 8. We just don't really think about them like this. Sure, you can have a decimal in your fraction. It's weird. We don't really do that. But 7.5/14 is in between 7/14 and 8/14. So all you do there is you make another equivalent fraction, multiply by 2, multiply by 2, because that's going to get rid of my 0.5, because 7.5 times 2 is 15, and 14 times 2 is 28. So here's how you got to follow the logic. This is the same as this, which is in between those, which is in between those. So 4/7 is bigger than 1/2, but 15/28 fits right in between the two of them. It's pretty crazy, but it works because you're making common denominators with equivalent fractions, and then you're finding fractions in between, and then you're doing it again. It's really quite interesting. Here's two more. And here's where you'll see something similar to the last one, where we get numbers that are very close together. So it would be hard to compare these. It would also be hard to find something in between without thinking mathematically through this. So first, common denominator. So I'll multiply that by 13 and that by 13. I'll multiply that by 12 and that by 12. 13 times 12 is 156. 12 times 12 is 144. And 11 times 13 is 143. So here I'm in a situation where, again, it seems like there's nothing in between. But really, you could pick any decimal after 143, but it's just good to go with 143.5. And then, yeah, you could multiply this by 2, right? Because 143.5 over 156, you can multiply by 2, because 2 times a half gets you a 1. So it just gets rid of our decimal, and you would end up with 312. So 287/312 is that fraction. It's in between those two things. You could also multiply this by anything to get rid of that 5. So you could multiply this by 10 and 10 because it's still an equivalent fraction. And you get 1560 and 1435. Just move the decimal over. This is exactly the same fraction as that fraction as well. So you can see you could find an infinite number of them. This is really bonus material. If you're watching this and you're stressing out, don't. This is for extension in grade 9. It's bonus, but it's just pretty cool. And all it involves is equivalence and common denominators. So that's our video there. The next one coming up here to wrap up section 1 is to wrap up our fractions, is how we can convert from mixed to improper and improper to mixed. Then we'll get into operations with fractions like addition, subtraction, multiplication, and division, and then we'll finish with order of operations. Thanks, everyone. Take it easy.